Today, I want to talk about Electron testing because that has been something that has been on my plate that I've been doing in the past, especially with my last company. I'm maintaining WebdriverIO, so I thought we could put two Electron technologies together and do a talk about this. I'm currently working at a company called Ionic. We built a front-end framework called Stencil. We have a framework that is called Ionic as well that allows you to build a mobile application using web technologies. I'm also maintaining the WebdriverIO framework on the side, which is a lot of fun. Today, in my next 20 minutes, maybe 30, we will talk about Electron. I will explain what Electron is for people who haven't heard about it. I will speak a little bit about WebdriverIO, and then we bring all these two things together and see how we can automate an Electron application using WebdriverIO. Pretty simple. Let's get started with Electron. Who of you has heard about Electron before? Okay, bunch of people. I guess there are a bunch of things that are not new to you. For people who don't know, Electron is a development framework that allows you to build desktop application for using web technologies for native desktops. So you have one framework that allows you to distribute the application on Linux, on Mac, or Windows. So many times ago, who remembers Atom, the IDE? Who used Atom? Probably a lot of people. Atom, we loved Atom. Like, I was my favorite editor of choice back in the days. Atom was the first hackable IDE that allows us, that was built using web technology, using HTML, CSS, JavaScript, like VS Code is today. And GitHub, the company who built Atom, they needed a way to distribute that IDE, and they built Electron as a side project to do that, to do exactly that. Now, moving on to today, Atom has been sunsetted by GitHub, and but Electron still remains the favorite choice when it comes to building desktop application. And I'm pretty sure every one of you has at least one Electron app on their machine that they use every day. If you see all these logos, you see how the variety of application you can write with Electron. There's basically no borders or no limit. You can write messaging applications like Slack or Discord. It goes into video streaming like Twitch, or like productivity apps like VS Code or Notion. So there's a lot of ways you can use and build Electron apps. A lot of things you can do with Electron, and there's really no border. And the good thing about, my favorite thing about Electron and myself is that it is built, or it's part of the OpenJS Foundation. So why is this impossible? If you're a company like Slack or Discord or Twitch, you distribute your software, your mission-critical software, through an open source project. And so if it's mission-critical like that, you want to look into the governance of how this open source project operates. You don't want that a company relicenses your open source project and puts some features behind a paywall. You also don't want that the development team of that open source framework stops working on the project and you have to move from one framework to another. So all the projects that are part of the OpenJS family are kind of like, the foundation works to make these projects as sustainable as possible. We all remember what happened with Unity, even though Unity is not per se an open source project, but there are other examples like Protector where from one day to another they announced that they want to discontinue the project, and we all had to look for a different testing framework. So the OpenJS Foundation hosts and governs projects with the goal that they stay available for as long as possible. And this is important when you choose Electron. This is important when you choose Electron as a building block for mission-critical software in your company. There's some interesting features on top of that makes choosing Electron over native frameworks interesting. For one, security. Even though this is always a debatable topic, Electron applications are by default secure. You can look into the source code of the Electron application, of course, but it can be as secure as any website on the internet. The Electron team actually has a working group within their project governance that constantly works on security issues and security concerns by their users. And they have been improving a lot the configuration defaults when you start building applications with Electron. They make it by default more secure, choosing certain default configurations. And they have a great guide on how you build Electron application in a secure way. Electron gives you all low-level accessibility features that you need for building, all kinds of stuff. You can, modify the touch bar icon. You can have access to the web preferences. Since you're running a software on a local machine, you can always, go into native code as well. So there's always you can interact like a native developer would do, using a native framework. Using web technologies, you can also do hardware access through Bluetooth or web USB. So I know a lot of crypto platforms. They write their wallets using Electron, and they use an USB to attach, to exchange tokens and keys. So that is all possible. Performance, another debatable topic when it comes to Electron, because Electron is based on Chrome, which I go to in a second, and we all know that Chromium can be a little bit memory hogging and consume a lot of memory. However, a basic Electron application is by default performant because it's simple HTML and CSS, which it can be run very performant. When you, however, build the application in a way that your JavaScript blocks a lot of times, then it can become unperformant. So it's all a matter of how you write an application, and it's always a trade-off. The memory stuff probably doesn't go away with Chromium under the hood, but for that trade, you get the nether feature or the nether feature of Electron, which is cost and time. Building one application and distributing it across all platforms is, for many companies, the best choice that they can have to set resources to build, have 3 teams to develop 3 applications. Instead, just have one team that develops one application and can distribute it across their whole user base, which is a big plus when it comes to Electron. And lastly, the distribution part. Whoever has built a mobile application probably knows the pain about getting a mobile application to the App Store. The Electron ecosystem has great tools to make distributing Electron application very easy. In my experience, many companies just have a download link on their website, but these tools also help you to move it to the App Store directly. And if you feel, Electron's a question?
Just a question real quick on security. Forgive my ignorance. Does Electron still adhere to the same origin policy of the modern web browser? So the question was from the audience, does Electron still adhere to the same origin policy as a browser? Yeah.
Yes, it does.
Okay.
I believe so. I'm not 100% sure, but I wouldn't be surprised if not. If you want to get started, I recently wrote my first Electron application, which I'm going to show you in a second. It's very easy. There's an Electron app starter kit. You just enter npm init Electron app, and then provide a folder name, and then it will basically set up everything for yourself. And there we go. You have an application that just is based on HTML and CSS. So if you know about HTML and CSS, you can write desktop application, which can be pretty cool. Whoever you remembers the time when one tab crashed because we were on a crappy website, and then the whole browser, all the tabs crashed at the same time? Well, that back in the days is because Chromium or the browsers used to run on a single process, and that means if one process crashed, all the other tabs would crash as well. And the browser vendors have changed that and became more performant by having one main Chrome process to manage the lifecycle of the application and move all the windows or web extension or whatever entities you have in the browser into a different process. And so, since Electron is based on Chromium, it uses the same model. You have one Chrome process manager, which is a Node.js application that have access to Node capabilities, has access to the system, and so on. And that process manages a bunch of rendering processes that basically render your HTML and CSS. And there are ways to, there's a context bridge interface that allows you to send messages across different windows and frames and access the Node.js process that allows you to do system stuff, to boot up application, to register icons, things like that. So Electron works in the same way. So now that we know how to build Electron applications, we can dive into, we've built an Electron application, we have to test it because we want to make sure that things stay all right. For that, there are plenty of tools you can use. I'm going to talk about WebdriverIO today. For people who don't know what WebdriverIO is, it's a mobile and browser automation framework that allows you to write tests in JavaScript to any remote device. Can be a browser, can be a mobile device, can be a TV. There hasn't been anything that hasn't been tested with it. And you can also test ElectronJS application. There's kind of like 3 layers to it. There's bare metal mode, standalone mode, and test runner. WebDriver by default uses the WebDriver standard to automate user agents. The WebDriver standard basically defines what a click means, and whoever implements the driver can then, based on the standard, do the same type of click in Chrome or on a mobile device. And so that's the advantage of using WebDriver. You can write one test in one framework and use the same framework to automate all the tests as well. And so the bare metal mode is basically almost like a HTTP client that allows you to directly connect with the protocol. And you have to know a bunch of protocol specifics to make use of it, but you have the really low-level access to the protocol. However, many people just choose the standalone mode if they want to automate things. And the standalone mode comes with a little bit opinions on it. There's like an element abstraction, and you have a browser object, and so there's some retry mechanisms in place. So some things that make automating a browser or mobile device a little bit easier. And if you want to run this in a whole test context, you can use the test runner, who basically spins up multiple processes in parallel, helps you with parallelization, has plugins and reporters and all that fun stuff.
Christian?
Yeah.
Quick question for you. Can you go back one slide? What do the hot, medium, and mild indicate for us?
So hot basically means it's like, it can break very fast, because if you don't know all the intricacies of a protocol, it's basically what it's going to do. And there's, for instance, also no retry mechanism. If you don't find an element, you have to make sure yourself that you make sure that the element is being found. Where the standalone mode, it has some retries in it. It has some additional features that make the automation process a little bit easier for testers. And then the test runner mode comes with the services and plugins, where you basically don't have to write anything anymore. So it's very mild and easy to go. And the way it works, how most of the test frameworks today works, is basically you have a script on the top left where you, with a test, you can select an element and interact with it. And what happens under the hood when you use Selenium or WebdriverIO, it basically sends an HTTP request to a driver which has the WebDriver protocol implemented. So that means the driver is basically an HTTP server that understands when you send a click command to a click endpoint, that it knows how to do that stuff that you want to do in the remote device. It can be a browser. So a Chrome driver would use the Chrome DevTools protocol to automate that click. For Safari, it's a different DevTools protocol under the hood. For mobile, it's the same. If you use Appium, which is currently probably the most used mobile automation framework, it understands that you want to click using the WebDriver protocol, but internally it uses XUI and ADB to actually make that click happening, whether you use a web browser on the mobile device or a native application. And so when we go to desktop testing, since Electron apps are using Chromium under the hood, we have to use the Chrome driver to translate the WebDriver commands into something that Chromium understands. Which brings me to the live demo. So I recently went to New York and visited or participated in the Open Source and Finance Forum, and I built a little attendee counter, an unofficial attendee counter. And you can all follow me along if you have a laptop to build this application or test this application with me. So you just click on this bit.ly link that I will show in a second, and it will pop up my project. So this is a little open source project that I have on my account. we will quickly install the dependencies, and we will start the application, and that will compile Stencil, which I use as a front-end framework to basically have my little Electron application up here. You can see that there are web components here. I can make this a little bit bigger. Oh, I have some web components here. Can I move this? Oh, I can move this. Perfect. So it's basically, an app root, and then I have some diffs in here. And so my goal is now to be able to see if I can click the button and that the counter goes up. It's very, very simple on purpose. So to get started, we can close it up. To get started on Electron development or testing, all you need to do is use the init command, and WebdriverIO will walk you through a little setup process. It will install the CLI, and then we'll verify that the project is correct. And WebdriverIO has various ways to do testing. You can do it on desktop, even for native macOS applications. So if you want to automate your calculator, you can do that as well through Appium. You can test VS Code extension or mobile and web. But for this time, for this example, we do Electron application. It will ask you for the builder, so the tool that compiles your Electron application. Right now, there are two popular tools out there, and the starter kit comes with Electron Forge. We use Mocker, and we basically stay with the default values here. So now I get a test that basically just gets the title, which is the application title of the application. And before we run the test, we have to package our application. So we use Electron Forge. We compile our front-end code. We use Electron Forge to make a binary out of it. This one is a little bit simple because we just compile to macOS, but you can set it to compile to Windows and Linux at the same time. And once that is compiled, all you need to run is npm run WDO, which is a script that has been added after the setup process. So you will hopefully see an application being pop up and disappear immediately, but you can see that we now have the title right here. And what you cannot see probably is the config file. WebdriverIO sets up everything for you. You don't need to worry about anything, but something important to point out is that you define a browser that is called Electron, because that tells WebdriverIO to kick off the service and the plugins in the background, to start the application, to download the right Chrome driver that is used to automate that specific Chromium version that you use for Electron. Electron usually is a couple of Chromium version behind. So when right now Chromium is on version 120, so Electron, the latest Electron might be on 114. I don't know for sure. But this is all what WebdriverIO needs to kind of like set everything up, gets every binary that you need downloaded, and get you up and running. And just to finish up the test, so what we want to do is just to test if the button click works correctly. For that, we just we will select the button, and I will use the deep selector for that, which is the three characters there, which basically allows me to go within the shadow DOM of an application. I think, I will show you in a second. But what I'm going to basically do, I define a variable, and then I would just click 3 times. Come on, Copilot, you know better than me. And then at the end, we say, OK, we want to have our button to have a text of, not 3, to have a text of, let's look into the, to just show a little bit about the Electron application, we have the app.ts is basically the Node.js process that basically defines a new browser window in a certain width and height, gives it a title, sets some images. So if maybe I just go back into the application, readme file, and start again. If you notice that, so something like, for one, you see probably in the button here, it's like the open open source. It's like the special logo. You can see it on there too. It's like the logo that I register, the window size, and a bunch of other things that you can define for an Electron app. And then in terms of selector, we have one app root where all my application is located, and it uses web components. So there's shadow root in it. And I'm using the deep selector so I can go into the shadow root to select the button that is right here, right there. And the text is attendee count something. So if I go back in my test, I would expect attendee count to be 3. Let's run that. So on this test, and then I have one more thing I want to show. So 3 point, I'm not sure if it was fast enough, but it was fast. But basically, you can see here in the logs that we first had an attendee count of 2, and here the test runner feature, if you use the expect that WebdriverIO gives you, it retries until for 5-6 seconds. So the first attempt of finding the right text failed, but then the third attempt of finding the right expectation passed, and so overall the test passed. So it's a little bit resilient and helps you to write, have less flaky tests. The last thing that I want to show you is with the feature, with the Electron service that is provided by the WebDriver project, you can hook into the Electron application during the runtime. So here I have a little bug in here, which means if I go over 6, there's a little alert that says that you have reached the limit of 6 clicks. So in my test, let's say I don't want to care about this alert because it would just hinder me to do certain automation. So what we can do is we can inject ourselves, or we can inject the framework into the application. So let's say we say it's when we test our application, we have to install a hook, which is all well documented. But I would just write it away. So if we compile the application in our test process, we don't want to push that in production, obviously. But during our test, we want to just inject this hook, which allows me to talk to the application at runtime. So that is we're working on that, getting this away, removing this requirement. But for now, that's needed. So for the preload script and for the app script, we need to inject that, and then we need to recompile our app to include that code. Let me just do that. And is test should be node environment. So we want to node env to be test, and we repackage that. And then we can go ahead in our test now, and we can do 3 more clicks, and without the alert being shown. And I will add a little pause in here, 4 or 5 seconds. And then we run this again. So we recompile the application with our hook installed. Oh, actually, see, I installed the hook, but I haven't changed anything. So this will happen now. The alert happens, and an alert is a system message. It goes outside of Chrome. So we could not actually test, click on the OK, because that's a macOS feature. That's a macOS UI thing. And that's outside of the scope of Chrome driver and whatever Chrome can automate. So this kind of often is the root cause of many issues that users have when they automate the application. So one way to get around this is just to say, OK, I don't want to have this alert being popping up during my test, because my test is not being concerned about this alert being there. So just let me find the location where it pops up. It's right here. So basically, my front end, I call an event, and that gets propagated into my Node.js script, where I have all the access to native interfaces, in this case, like the dialog, which is an Electron interface. And so what the service provides you, the WebdriverIO service, is now to say, OK, in my browser, there's an Electron interface that you can use to execute a script inside the Node.js environment of that application at one time. So that is a little function that you pass in, that method, and that function gets the Electron object that you get that you can import in your application. And with that, we can just say the Electron dialog interface will be just a no-op message or no-op function. So we don't do anything. I can just mock it out. And we're actually currently working on a jest vtest kind of like mocking API where you can just say mock this out and give me how many times I actually called this interface. So it's like a more streamlined in like how you can test interacting with Electron interfaces and like mocking things out and get the information on how often it's been called, with what kind of parameters it has been called. So it gives you some way to test how your backend of your application actually behaves. So with that in place, I can just rerun the code, and fingers crossed it should not show. Oh, this time it's probably a TypeScript thing. Oh yeah. So I'm using currently Electron Insiders because for some reason my TypeScript language server doesn't work for VS Code anymore. But because I tested this before, so the types are not happy, but it's not shown in my IDE because my language server is fucked up. But just casting to any. There we go. The pop-up is not there. This is now my pause, which happens to show the application. But now I was able to make the 6 clicks without having the alert come into my way and making my test flaky or not. This was the demo. So you can, if you want to check this out or follow along, there's a bit.ly osff-demo, and we'll open your VS Code and we'll set up everything for you so that you have that application and you can then set up WebDriver if you want to. With that, that's all I have for today. I'm happy to answer any questions.